Good afternoon, class. We are looking at Chapter 5, Polynomial and Rational Functions, 5.4, Dividing Polynomials, 5.5, Zeros of Polynomial Functions. So 5.4, Dividing Polynomials, 5.5, Zeros of Polynomial Functions. The objectives are: use long division to divide polynomials, use synthetic division to divide polynomials, evaluate a polynomial using the remainder theorem, use the factor theorem to solve a polynomial equation, use the rational zero theorem to find rational zeros, find zeros of a polynomial function, use the linear factorization theorem to find polynomial with given zeros, use Descartes' rule of sign, solve real for the applications of polynomial equations. So here's the summary. Everybody remembers polynomial functions by definition. F of x equals a sub n x to the power of n plus a sub n minus 1 x to the power of n minus 1, all the way to a sub 0, where a sub n can't be 0 and n must be a whole number meaning 0, 1, 2 to infinity with the domain of negative to positive infinity. Degree of the polynomial function is n. Graph is smooth and continuous. Maximum number of turning points is n minus 1. At the zero of even multiplicity, the graph touches the x-axis. At the zero of odd multiplicity, the graph crosses the x-axis. Between zeros, the graph of f of x is either above or below the x-axis. N behavior: for larger the absolute value of x, the graph of f of x behaves like the graph of a sub n, y equals a sub n x to the power of n. As an example, a polynomial of degree 1, p of x equals mx plus b, is a linear function, and a polynomial of degree 2, p of x equals ax squared plus bx plus c, is a quadratic function, as you all remember. In the case of a quadratic function, the vertex x has coordinates minus b over 2a, and y has coordinates f of minus b over 2a. You plug in. And now the new sections: 5.4, dividing polynomials, and 5.5, zeros of polynomial functions. A division algorithm for polynomials: n of x, numerator, over d of x, the denominator. Let n of x and d of x be two polynomials with a degree of d of x greater than 0 and less than the degree of n of x. Then there exist unique polynomials q of x and r of x such that n of x over d of x equals q of x plus r of x over d of x. In other words, if you want to divide, it gives you the quotient and it gives you the remainder. So the other way you can write that n of x is the product of these two, q of x and d of x, plus r of x. Dividend is equal to the quotient times the divisor plus the remainder, where either r of x is 0 or the degree of r of x is less than the degree of d of x, the denominator. Here's the remainder theorem. If f of x, a polynomial, is divided by x minus c, then f of c is the remainder, f of x over x minus c, or is f of c. All you have to do, plug in. You can either do the division or evaluate it at c. Factor theorem is if f of x, a polynomial, is divided by x minus c and f of c becomes 0, then x minus c is a factor of f of x, or f of x over x minus c. That means the remainder must be 0. So in short, the remainder theorem, f of x over x minus c, the remainder is f of c, and the factor theorem, the remainder is 0. That's the general idea as far as the division is concerned. Let's look at the division process. You probably remember that from previous courses. We want to divide 3x cubed minus 2x plus 5 by x minus 3. So how do we get that started? We're going to write it in this format. And Since this is of degree 3 and the second degree term is missing, you can either write 0x squared or just give it some space. Understand the second degree term is missing. And you start with the first one, 3x cubed, and you divide by the first. And you get 3x squared. Now you put the 3x squared here, and you multiply by the divisor. So when you multiply these two, you get 3x cubed minus 9x squared. And you have to subtract this from up here, just the way we did it with numbers. We subtract this from this one. You subtract this one from this one. That means you can change the sign and add them up, 9x squared. We can bring the next term, negative 2x, down. And again, we're going to divide 9x squared, the first term that we have, by the first term of a divisor. So divided by x, it results in 9x. So you're going to add a 9x here. And now you're going to multiply these two. 9x, you multiply it by the divisor, and you get 9x squared minus 27x. And you're going to subtract. When you subtract, you can change the sign here, make this is another way of doing that, class. You can change the sign here to negative, this one to positive, these two cancel each other, and these two add up to 25x. And of course, we bring the 5 down. And we repeat the process. The first one, the first term is now 25x. By the first term, x results in 25. So add 25 here. Multiplied by x minus 3, it results in 25x minus 75. And we are going to subtract again. When you subtract, again, you can change the sign here. It changes here. You change the sign here. And you add up, you get 80, which is the remainder. So that's the process similar to long division of numbers. Therefore, we are going to write this division has this answer, 3x squared plus 9x plus 25, with this remainder 80 plus 80 over x minus 3. You could also write this as this is equal to x minus 3 times the quotient, 3x squared plus 9x plus 25 plus the remainder 80. And we're done. That's the dividend, that's the divisor. That's the remainder, that's the divisor. So you can write it in this format or in this format. Now, this is the whole process in one shot of the previous page. So if we just ignore the variables and we just write the numbers, I want to go over this concept known as the condensed version, ultimately synthetic division. So if you write the same thing but without the variables, for example, this one is 3, this one is 0, this one is minus 2, this is 5. Do you see that? This one is 1 minus 3, and the rest of them. So look at this, and what are we using? This one. Look at these three numbers. The reason you go with a positive here, because you put negative here and it takes care of that. Look at those numbers, you put them including the sign. And this is the final answer, 3. If you go back here, the degree was 3. for the quotient, the degree goes down by 1 because this has a degree 1. So the difference 3 minus 1 is 2. So 3x squared, 9x, 25, and this is the remainder. And this abbreviated form of long division is called synthetic division. Let's look at a couple of examples. We're going to divide 6x squared plus 5x minus 10 over 2x plus 3. So let's write it in this format. And we're going to divide the first term, 6x squared by 2x. It results in 3x. And we're going to multiply the 3x by the divisor. It gives us 6x squared plus 9x. We are going to subtract this from the top. So you can change the sign to negative. I'm going to put the negative down here so you see it was originally positive. And these two cancel each other. And these two, positive 5x, negative 9x, they add up to negative 4x. And of course, when you bring this down, you get minus 4x minus 10. We are going to divide the first term by the first term. Negative 4x divided by positive 2x results in negative 2. And now we're going to multiply the negative 2 by 2x plus 3. We get minus 4x minus 6. And we are going to subtract. Therefore, you can change the sign and add them up. And this gives you negative 4. Which means, let me just clean up the mess. Which means, when you do this division, the answer is 3x minus 2 with the remainder of negative 4. So you could write it in this fashion, 3x minus 2 plus negative 4 over 2x plus 3. Again, I want to make sure we understand this. We could also write this, just the top equals the product of the divisor 2x plus 3 and the quotient 3x minus 2, and add to it the remainder negative 4. Let's do this one. And again, we start with the first one, 5x cubed divided by x squared. We get 5x. We're going to multiply 5x by the divisor. And by the way, it's x squared plus 0x plus 1. In this case, if you don't put it, it's fine. Just if I multiply this, I get 5x cubed. If I multiply this, it is still 0x squared. And if I multiply this one, is 5x. You don't have to do this. Just make sure when you line them up, you line them up such that this is under x cubed. This doesn't exist. It's fine. You can think of it as 0. And this is under 7x. Now we are going to subtract, everybody. And to do so, one easy way is to change the sign. So this becomes negative, this becomes negative, this becomes negative. These two cancel each other. These two add up to negative 4x squared. These two add up to positive 2x. And we can bring the negative 2 down. I hope it's pretty clear, everybody. What happens next? Let me clean up again. Now we are going to divide the first term, minus 4x squared, by the first term, x squared. And we get minus 4. We are going to multiply the negative 4 by the divisor. We get minus 4x squared minus 4. Of course, whether you write this or not is not important as long as you understand you're lining up like terms. Now, remember, since you are going to subtract this from the previous one, you can change the sign. This becomes positive, cancel each other, positive, that's 2x, positive. Okay, that's positive 2. So 2x plus 2 is the remainder, everybody. And I believe that's pretty straightforward. So how do we write this guy? We write the answer is 5x minus 4 with the remainder 2x plus 2 over x squared plus. Second way of writing it, again, just to make sure we understand what happened here, we could also write it in the following manner. We could write this is equal to the product of the divisor x squared plus 1 and the quotient 5x minus 4 and add up the remainder 2x plus 2. That's another way of writing. Use the remainder and factor theorems, and reminding you, remainder theorem, basically f of x divided by x minus c, you plug in c and evaluate it into function. Factor theorem, you do the same thing and it ends up being 0. So find the remainder if f of x is given as x cubed plus 3x squared plus 2x minus 1, and we want to divide it by x plus 2. It's important to understand this is x minus c. So comparing it to x minus c, you want to evaluate f of negative 2. F of negative 2, everybody. So negative 2 cubed plus 3 times negative 2 squared plus 2 times negative 2 minus 1. So again, we are dividing by x plus 2. So this is f of x minus 2. I can't emphasize this enough. And so, and negative 2 cubed is negative 8. And negative 2 squared is positive 4, so plus 12. And then 2 times negative 2 minus 4 minus 1, they add up to negative 1, and the remainder, therefore, is negative 1, everybody. So that's pretty straightforward. We are going to look at the next one, x minus 1, and simply put, you want f of 1. And that's something, again, I want to make sure that we are comfortable with. F of 1. So that means what? 1 cubed plus 3 times 1 squared plus 2 times 1 minus 1. And so we have 1. This is 3 times 1 plus 2 minus 1. And they add up to 5. The remainder, therefore, is 5. Use the factor theorem to determine whether the function f of x equals negative 2x cubed minus x squared plus 4x plus 3 has the factor x plus 1, x minus 1. So there are two factors we want to check, everybody. The first one, x plus 1, we have to evaluate f of negative 1. For this one, f of negative 1. And that's something that everybody want to be very careful. X plus 2, f of negative 2. X minus 1, f of positive 1. Over here, x plus 1, f of negative 1. So plug in, we get minus 2, negative 1 cubed, minus negative 1 squared, plus 4 times negative 1 plus 3, And so, this is -1, so we get +2 here. This is +1, we get -1 here. Then we get 4 times -1, -4, +3. As you can see, they add up to 0. Therefore, the answer is yes. X plus 1 is a factor of f of x. What about x minus 1? We have to evaluate this function at 1. You have to evaluate the function at 1. So simply put, -2 times 1 cubed minus 1 squared plus 4 times 1 plus 3. That's all there is to it. And 1 to any power is itself 1. So this is -2 minus 1 plus 4 plus 3. The answer is 4. Therefore, x minus 1 is not a factor of f of x, because in order for it to be a factor, the remainder must become 0, and that's not the case here. Use the remainder and factor theorem. Use the remainder theorem and synthetic division to find p of -2 if p of x is minus x to the power of 4 plus 3x squared minus 4x minus 5. I'm going to go through this fast. A couple of synthetic division. I'll show you the process, but in short, you should be pretty comfortable with that. So let's start writing the synthetic division for this one. So all we need, write all of them in descending order. So this is -1. I don't see x cubed, then I have to go with 0, then 3 minus 4 minus 5. I need all of those numbers. But again, if for the sake of a long division, even if you don't use a placeholder, it might work. In this case, it will not work. So I'm going to repeat, -1. There's no x cubed, 0, 3 minus 4 minus 5. And we want p of -2, so we put -2 there. Okay. Now, the very first thing we do, we just drop this just the way it is. The very first coefficient, which is -1, you just drop it, you don't do anything. Then you start multiplying them by this number that is given here. So let me use this color. So we are going to multiply this by -2. We get +2. We add these two, and we get +2. We keep repeating the same thing. We multiply by the same number, -2, results in -4. Add these two, we get -1. Multiply by -2 again, we get +2. Add these two, we get -2. Multiply by -2, we get +4. Add these two, we get -1. So I think it's pretty straightforward, everybody, but you need to practice a little bit. So I'm going to rewrite this, and what it means is the answer. So x to the power 4, right? The exponent is 4. So this means minus x cubed plus 2x squared minus x minus 2. Here's the remainder. Because the remainder is not 0, this is not a factor. You could take the easy way out. Evaluate p of -2. If you plug in -2 here, you come up with the answer a lot faster. You don't have to do the synthetic division unless you're asked. But whether you use the synthetic division or a remainder theorem, again, what is the remainder theorem? Plug in -2, evaluate it as I did it in the previous page. It goes much faster. Decide whether the given number is a 0 over p. P of x, and you can plug in 2 or do the synthetic division. I'm going to just show you the result. If you plug in P of 2, both of them give you 0. So this is the faster way, class. I'm showing you the synthetic division. So the remainder is 0. And therefore, x equals 2 is a 0 of the function P of x. You can say it's a 0 of the function. You can say it's a root of the function. You can say x minus 2 is a factor of this function. They all mean the same thing. So let me recap. You can say x equals 2 is a 0 function. You can say x minus 2 is a factor of the function. You can say x equals 2 is the root of the function. How about negative 2? Again, you can plug in minus 2 and evaluate it. P of negative 2 and evaluate it. That's all there is to it, class. You can do that. Okay. Or you can do the synthetic division. Either way is fine. Now, what is the remainder? Negative 19. Therefore, negative 2 is not a 0 of P. And as I mentioned, this is probably a faster way, going with the remainder theorem. Plug in negative 2 and evaluate that. I'm going to leave it for you to actually practice with both. I have given you the solution for both cases. I highly recommend you try both of them and get comfortable with them. But as I said, if they don't ask you what method, obviously the factor theorem is a lot faster, okay? Which becomes a remainder theorem is a lot faster, which becomes a factor theorem here, and it's just a remainder theorem. The rational zeros theorem. If f of x is a polynomial, a sub n x to the power of n, all the way to a sub 0, where a sub n can't be 0, is a polynomial with integer coefficients. If p over q in lowest term is a rational 0 of f of x, then p is a factor of the constant term a sub 0 of f of x, and q is the factor of the leading coefficient a sub n of f of x. In other words, this one, factors of the constant over factors of the leading coefficient. Number of zeros. A function defined by a polynomial of degree n has at most n distinct or unique complex zeros. Some of them may be repeated, okay, class? So we could have repeated roots or zeros. Descartes' rule of sign determines the number of positive and negative zeros. Let f of x be the above polynomial function with terms in descending power of x. The number of positive real zeros either equals the number of variation in sign occurring in the coefficients of p of x, or is less than the number of variations by a positive even integer. The number of negative real zeros either equals the number of variation in sign occurring in the coefficients of p of minus x, or is less than the number of variations by a positive even integers. In other words, after you look at this one, for example, if the numbers end up being 7, then you can say the possibility is 7, or go down by 2, 5, 3, 1. That's the idea. Use the rational zeros theorem to list the potential rational zeros of a polynomial function f of x equals 3x cubed plus 8x squared minus 7x minus 12. And we're going to go with the rational zero theorem. First and foremost, the degree is 3. That means at most we can have 3 real zeros. Now, factors of a sub 0 we represented as a p. So factors of a sub 0, that means factors of negative 12, over factors of a sub n, that means factors of 3, everybody. So p represents factors of negative 12. Now, I hope you realize, and you have to write plus minus. So plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 12. I hope you realize that. And 3 is just plus minus 1, plus minus 3. So P is those numbers, Q is those numbers, and here's the ratio that we are going to look at, everybody. So what this rational zero theorem tells us, these are possible solutions. So for example, if you divide these two plus minus 1, if you divide these two plus minus 2, these two plus minus 3, plus minus 4, plus minus 6, plus minus 12. Now let's divide them by plus minus 3. So plus minus third, plus minus 2/3, plus minus 1, we don't have to repeat it again, plus minus 4/3, plus minus 6/3, which is plus minus 2 again, we don't have to repeat it, plus minus 12 divided by plus minus 3, that means plus minus 4, we don't have to repeat them. So there are so many of it, okay? There are so many of it. So what this says, if this function has rational zeros, has to be some of this, okay? For example, you can't make up a number and say, okay, let me try number 7. No, it's not going to work. It's not among these numbers. So find the real zeros and write f of x in factored form. Now, to do that, you start checking. For example, 1, negative 1, 2, negative 2, 3, negative 3, and so on and so on. Always go with the easy one. If you plug in 1, actually, it doesn't work. It's easy to see 3 plus 8, 11, minus 7 is 4, minus 12 is minus 8. So let's try negative 1. When we plug in negative 1, we get 3 times negative 1 cubed, plus 8 times negative 1 squared, minus 7 times negative 1, minus 12. So this is negative 1, so we have minus 3. This is positive 1, we have plus 8. And this is plus 7. This is still minus 12. And I hope you see that they add up to 0. Therefore, negative 1 creates the factor of x plus 1. So we got one factor, x plus 1. So then what do? We do the synthetic division to find the second degree function. When we divide this function by x plus 1. To divide this by x plus 1, we do the synthetic division, and we are going to write 3, 8 minus 7 minus 12, 3, 8 minus 7 minus 12. This one must be negative 1 in the case of a synthetic division. In the case of a long division, simply you divide by x plus 1. It's important to understand that. You would put, so this corresponds to x plus 1. And so we go through the process. This, you drop it, you multiply this one by negative 1 minus 3, and 8 is 5. You multiply this by negative 1 minus 5, and minus 7 is minus 12. You multiply by negative 1, you get positive 12, and negative 12 is 0. Therefore, if I divide this function by x plus 1, it gives me 3x squared plus 5x minus 12. So one more time, f of x is this, equals, because f of minus 1 is 0, x plus 1 times 3x squared plus 5x minus 12. Now, you can continue working with the rest of the numbers to see what happens, or it's a second degree. You can factor it. You can use the quadratic formula on that. And it's simple factoring because 3 is a prime number, everybody. So just this part has x and 3x, and now you try number -12, which is the product of 1 and 12, one of them negative, 2 and 6, one of them negative, 3 and 4, one of them negative. And it works out that this becomes x plus 3 times 3x minus 4. As you can see, if you were to set this equal to 0, this gives you -3, and this gives you +4 thirds. We have them along those numbers. And therefore, we are done with finding the factored form. So what are the zeros? If you set this equal to 0, that means x is -1 here, x is -3 here, x is 4 thirds here, because it's asking for zeros of the function. Use the number of zeros theorem and Descartes' rule of sign to discuss real zeros of f of x. So f of x is 3x to the power of 7 minus 4x to the power of 4 plus 3x cubed plus 2x squared minus x minus 3. So first and foremost, the degree is what? 7. So the maximum number would be 7 of zeros. Secondly, notice, let's just write the signs, positive, negative, positive, positive, negative, negative. So this changes from positive to negative. This changes from negative to positive. There is no change here. This changes from positive to negative. There is no change here. So the change for sign, this is 1, this is 2, this is 3. There are 3 changes. So positive real zeros could be 3. Now, for the negative real zeros, we're going to evaluate f of minus x. To evaluate f of minus x, when you replace the x with negative x, this becomes minus 3x to the power of 7. This remains the same, so minus 4x to the power of 4. This becomes minus 3x cubed. This remains the same. This becomes minus x, which is plus x, and this remains the same. So f of minus x is what you see here. So what do we have here? Let's just write the signs, negative, negative, negative. Now from here to here, there is one change. Positive, positive, no change. Positive, negative, one change, one more change. So we have one change here, the second one here, and therefore there are 2 possibilities for negative signs. In other words, positive real zeros is either 3, or we're going to go down by 2, 1. Negative, we have either 2 or go down by 0. Now, please understand the second part of the theorem says that you have to go down by 2. So if this is 3, you can go down to 1 and there is no more. If it's 2, you can go down to 0 and no more. Okay, but if it were like 10, go down to 8, 6, 4, 2, 0. That's the idea. And one might say, okay, if n is 7, why do we have those? Some of them may be repeat, or they may be that we have more of them complex zeros, okay, a plus bi, and they happen in pairs. So 2 more maybe complex zeros. So that's another concept coming up. So determine the possible number of positive real zeros and negative real zeros of p of x equals x to the power of 4 minus 6x cubed plus 8x squared plus 2x minus 1. And we're going to do the same thing. We're going to notice the sign, everybody. So although it doesn't have a sign means positive, I'm going to put a positive on purpose so everybody can see that there's a change here. There's another change here, no change here, and there's a change here. So that means 1, 2, 3. There are 3 possibilities for a positive. Therefore, either f has 3 or 3 minus 2, 1 positive real zeros. For negative, we have to evaluate p of minus x. So if I replace the x with negative x here, this doesn't change. Let's do that. Okay. Minus x to the power 4 minus 6 times minus x cubed, so on and so forth. This doesn't change. It's x to the power 4. This one is minus x cubed minus 6 become positive 6x cubed. This is x squared, so plus 8x squared. This is minus 2x. This is minus 1. When we do that, notice positive, 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 no changes so far. Just one change, because this is negative to negative. So since there is only one variation in sign, p of x has only one negative real root. And you can't subtract 2 becomes negative, okay? So for a positive, we have either 3 or go down by 2 becomes 1. For this one, we have 1. So if we happen to have 3 and 1 here, the total is 4. But if we happen to have 1 here and 1 here, there is 2 more left. That must be complex. A plus b r and a minus b. Find the real zeros of a polynomial function and write this in factored form. Let's try this concept. The degree is 4. We have at most 4 real zeros. So according to this, we have factors of a sub 0, 9 over factors of a sub n 2. And according to the rational zero theorem, then this gives you plus minus 1, plus minus 3, plus minus 9. This gives you plus minus 1 and plus minus 2. And here's the ratio. If you wanted, I'm going to write this as class for 9 plus minus 1, plus minus 3, plus minus 9. For 2, plus minus 1, plus minus 2, and it results in the following. So what you have to do, you have to use those, and you can try one. I hope you see that if you plug in 1, you get a positive value, 2, plus 13, plus 29, plus 27, plus 9, which is not 0. So you plug in negative 1, you get 2 times negative 1 to the power 4, plus 13 times negative 1 cubed, plus 29 times negative 1 squared, plus 27 times negative 1, plus 9. And I'm going to leave it for you to verify that they do add up to 0. So what does it mean? It means that the function has a factor of x plus 1. If I want to go with the long division, I would go with x plus 1, divide this one by x plus 1. Or if I want to go with the synthetic division, f of minus 1 is 0, I put minus 1 here, and then 2, 13, 29, 27, and 9, and I do the synthetic division. Again, I'm not going to go through the synthetic division. We have done quite a few of them. I want to just quickly remind you. You put these numbers, these coefficients, 2, 13, 29, 27, and 9 here. You put this negative 1 here. You drop the 2, just the way it is. Multiply these 2, you get negative 2. Add them up, 11. Multiply these 2, negative 11. Add them up, 18. Multiply by negative 1 minus 18 with 27, positive 9. Multiply by negative 1, negative 9, and 9, 0. And that is what is expected. Now, what does this mean? This means f of x is x plus 1 times, now this has exponent 4, it's going to go down by 1. So 2x cubed plus 11x squared plus 18x plus 9. So that's the meaning. Now, when you are using this concept of a synthetic division to find more, because this is of degree 3, we're going to continue with the synthetic division. You can try one more time by -1, because sometimes the degree is such that it has x plus 1 with a multiplicity 2. So we are going to repeat the same thing with -1, and this time we have 2, 11, 18, and 9. Synthetic division again. 2, 11, 18, 9, and we're going to try with -1 again. So we drop the 2, we multiplied by -1, minus 2 and 11 is 9. We multiplied by -1, -9 and 18 is 9. 9 times -1 is -9 and 9 is 0. What does that mean? That means this is divisible by x plus 1. What does that mean? It means f of x is x plus 1 squared times what you see here, which is 2x squared plus 9x plus 9. And so now you use the factoring again, or if it doesn't work, if the factoring doesn't work, the quadratic formula, it's faster than trying other numbers. Otherwise, you have to keep on trying, class. So this is not too bad, again, because 2 is a prime number, so you have to go with x and 2x, and 9 is easy. It's either 1 and 9 or 3 and 3. And so it ends up being x plus 3, 2x plus 3. And so if you set this one equal to 0, that means x equals -1. Of course, it's a double root. That means it repeats. X equals -3 and x equals -3/2. All of them are here, okay? But this last part, the quadratic function, makes it easier to evaluate. Now, what is the solution to the equation 2x to the power of 4 plus 13x cubed plus 29x squared plus 27x plus 9 equal to 0? The same. That's really the meaning of all of those. The answer is the same, everybody. Bounds on zero theorem. Let P of x define a polynomial function of degree n greater than or equal to 1. With real coefficients and with a positive leading coefficient, if P of x is divided synthetically by x minus c, and if c is larger than 0 and all numbers in the bottom row of the synthetic division are non-negative, then P of x has no 0 greater than c. C is the upper bound. In other words, when we look at the result, if c is less than 0 and the numbers in the bottom row of the synthetic division alternate in sign with 0 considered positive or negative as needed, then P of x has no 0 less than c. C is the lower bound. So a simple example to make sure we understand what this theorem says. We want to show that this function P of x equals 2x to the power of 4 minus 5x cubed plus 3x plus 1, okay, has real 0 such that no real 0 is greater than 3 and no real 0 is less than -1. That means the bound. And the importance of that is that if there is no real 0 larger than 3, when the rational zeros are done and you have numbers larger than 3, you don't have to worry about them. Okay? And no real zeros less than -1. So we start doing the synthetic division with number 3. So we're going to put 2, -5, 3, and 1 with 3. I'll show you the result because, class, it's very straightforward. We've done this many times, and I'm going to quickly explain that to you just to make sure we understand that. So 2, you drop it. Multiplied by 3, you get 6. 6 and -5 is +1. 1 times 3 is 3. 3 and 0 is 3. 3 times 3 is 9. 9 and 3 is 12. 12 times 3 is 36 and 1, 37. All of them, according to this, if c is positive, that means this number, and it is. And all numbers in the bottom, the result of this division, are non-negative, then that's the bound. Okay, so all are non-negative, no real 0 greater than 3. By the way, if 3 is the bound, of course, if you choose 4, anything less than 4 will work, anything less than 5 works, but we are hoping to get the smallest positive number. It makes life easier that way. So I hope everybody is following as to why we do that. Now let's do it with -1. When we go through the process, 2, 4, -5, 3, and 1. Okay, and by the way, between these two, the x squared is missing. That's why we have 0. I can't emphasize this enough, and I believe everybody knows what we're talking about here, right? So having said that, you drop the 2, multiplied by -1, you get -6, and -5 is -11 here. Okay, -1. Okay, 2 times -2. So this is a mistake, class. Okay. 2 times -1, -2 and -5 is -7. -7 times -1 is 7, and 0 is 7. 7 times -1, -7, and 3 is -4. And -4 times -1, +4, and 1 is 5. Notice positive, negative, positive, negative, positive. They alternate in sign. Therefore, no 0 less than -1. That is the bound, everybody. That is the bound. And I can't emphasize this enough, okay? This is truly helpful. All right. Find the real zeros of polynomial functions. Write f of x equals 2x cubed plus 11x squared minus 7x minus 6 in factored form. Well, rational zero theorem. Okay, the degree is of course 3, and maximum number of zeros would be 3. The rational zero theorem says factors of a sub 0, that means factors of -6 over factors of 2. As you know, this one, let me just write it at top so you can see that. For -6, we have ±1, ±2, ±3, ±6, and for 2 is ±1, ±2. So when you do the division, dividing by 1, you keep all of them, and dividing by 2, this is ±1/2, this is ±1, which is the same, ±3/2, and ±3, which is the same as what we had before. And so again, you can start with some numbers. For example, plug in 1, 2, and 11 is 13. -7 and -6 becomes 2. It doesn't work. It so happened after you go through that, f of -6 works out, and I'm going to leave it for you to verify that this is 0. Therefore, if -6 is a 0, then this is divisible by x plus 6. Let's divide this by x plus 6 using the synthetic division 2, 11 minus 7 minus 6, and put a -6 here. Now you drop the 2. Then you multiply this by -6, you get -12, with 11 is -1. Multiplied by -6, +6, and -7 is -1. Multiplied by -6, +6, and -6 is 0. So this is the product of x plus 6, and now this is cubed, so it goes down 2x squared minus x minus 1. And again, you can factor this. In fact, it can't get any easier than that. 2 is a prime number, is 1 and 2. So this is x, and then 2x. And you want two numbers, the product is -1, the sum is -1. The product is -1. And then the middle term must work. So obviously 1 and -1, where does it go? You have to do the trial and error. Okay. So you do that, and you get x plus 6 times 2x plus 1 times x minus 1. As far as the terminology, in some texts, they call this 2x squared minus x minus 1 is called depressed equation of f of x, meaning it's been divided by some factor. That's the terminology that is used. So what are the zeros? X equals minus 6, x equals negative 1/2, x equals positive 1. Use the theorem for bounds of zeros. Example 11, given f of x equals 2x cubed plus 11x squared minus 7x minus 6. Find integer upper and lower bound on the zeros. And we remember the rational zero theorem. We did this. This is the previous example. We are repeating the example. So we are repeating this from the previous page. Okay. So how do we find this? The process is, for the upper bound, start with the smallest positive integer and move up. The positive integer, the smallest one is 1. See, we have positive 1, positive 2, positive 3. Because we want a bound, we are hoping on the positive side, we go with the smallest of the two. So we go with 1. And when we do the synthetic division, we end up having a 0. It doesn't have to be a 0 as long as we have a positive value, or for that matter, f of 1 gives you that. Doesn't have to be 0 as long as it's any number that is positive here or 0. Now, that gives you 0 if you go with that process. Lower bound, start with the largest negative integer and move down. Remember that when we say that the negative integers are -1, -2, -3, and so forth, the largest one is -1, everybody. Okay, the largest negative. So you work on -1, you work on -2, and so on to see what happens. So I'm going to give you the table. When we worked on 1, we came up with this answer. I want you to look at the last column, which is the remainder also. Okay, it happened to be a 0, which means that is a factor. But here's the upper bound. We start with -1. Okay, they don't alternate. We have to continue with the next one. -2, they do not alternate. -3, they do not alternate. -6, they do not alternate. -7, we get 2. -3, 14, -1, 4. They do alternate. So this is the upper bound, +1. This is the lower bound, -7. So we're going to write the upper bound is +1. And the lower bound is -7. Needless to say, this is just taking some time, but that's the way it goes. Now, consider the polynomial function p of x equals 2x cubed plus 5x squared minus x minus 6. Show by synthetic division that -2, -3/2, and 1 are zeros of p, and write p of x in factored form. So you can do the synthetic division because they ask, or you can use the factor theorem if you plug in -2 here, -3/2, and 1. So as an example for -2, first you have to write 2, 5 minus x minus 6. Okay, you write that. Okay. And then 2, you drop it. Multiplied by -2 is -4, and 5 is 1. Multiplied by -2, -2, and -1 is -3. Multiplied by -2, +6, and -6 is 0. So we showed that it's divisible by x plus 2. In other words, x plus 2 is a factor. Okay. So p of -2 is 0. We work with -3/2, or p of -3/2 is 0. We work with 1. We get the same thing. P of 1 is 0. So we have shown that this one is a factor, x plus from here, From here, we have x plus 2 as a fact. From here, we have x plus 3 halves as a fact. From here, we have x minus 1 as a fact. Now, if we multiply them through, the leading term is not true. So I want you to pay attention what happens. So for now, ignore that. So x plus 2, x plus 3 halves, x minus 1. If you don't have the x, if you just ignore it for now, when you multiply them through, the very first term is x cubed, so 2 is missing. So you have to pay attention that this one has 2, and therefore you need a 2. So this 2 comes from the fact that your leading coefficient is 2, and this 3, when you multiply them, the leading coefficient will be 1. In other words, if you multiply this 3, you get x cubed, and the rest is not important. You can do the math. So 2 is missing. You have to put the 2 in there. Okay, everybody? Graph it in a suitable viewing window and locate the x-intercept. So calculator, again, gives you -2, -1.5, and 1. So you graph it. You can locate the zeros. I have it in previous lectures, how to find the zeros and how to graph it. Okay, so you put y1 and the function. And to find the zeros, you go to calculator, second trace, 0, left bound, pick a value, right bound, pick a value. Guess, enter those, and give you the same answer. So these are the answers that are the same as what we did when we went through the synthetic division. Solve the polynomial equation. Well, the answers are the same. If you set this one equal to 0, that means you're setting this one equal to 0. That means x is -2, x is -3 halves, x is +1. So because the zeros of P are solutions of P of x equals 0, the solution set is -2, -3 halves, and 1. Complex zeros, fundamental theorem of algebra. Fundamental theorem of algebra says every function defined by a polynomial of degree 1 or more has at least one complex real or imaginary zero. If P of x is a polynomial of degree 1 or more, then there is some number k such that P of k equals 0. In that case, P of x becomes x minus k times Q of x, where Q of x can also be factored, resulting in P of x equals a times x minus k sub 1, x minus k sub 2, all the way times x minus k sub n. For every complex polynomial function f of degree n larger than or equal to 1, we can factor it into n linear factors, not necessarily distinct of the form f of x equals a sub n, x minus r1 times x minus r2 times x minus r3 all the way to x minus r sub n, where a sub n, r sub 1, r sub 2, r sub 3, r sub n are complex numbers. That is, every complex polynomial function of degree n larger than or equal to 1 has exactly n complex zeros, some of which may repeat. Remember, the multiplicity counts. Conjugate zero theorem. If P of x defines a polynomial function having only real coefficients, and if R is a plus bi is a zero of P of x, then the conjugate R bar a minus bi is also a zero of P of x. A polynomial function P of x of odd degree having only real coefficients has at least one real zero. Why is that? Odd. Remember, complex conjugates, they happen in pair. Complex conjugate zeros happen in pair. So if for example, n is 3, then 3 minus 2, there is one real zero. You can't have complex conjugates not happen in pair. That's the reason. Every polynomial function with real coefficients can be uniquely factored over the real numbers into a product of linear factors and or irreducible quadratic factors. So Here's an example. We want to find a polynomial to make some sense out of this. We want to find a polynomial of polynomial f of degree 4 whose coefficients are real numbers and that has the zeros 1, again 1, and 4 plus. You can say 1 or 1 with multiplicity 2. Either way is fine. So this means x minus 1, this means x minus 1, or basically these two mean x minus 1 quantity squared. 4 plus I is a complex number. It happens in pairs. So if 4 plus I is a solution, so is its conjugate. So 4 plus I is a 0 by the conjugate pair. Theorem 4 minus I is also a 0. So we have x minus 1, x minus this, and x minus that. So x minus 1, which means x minus 1 is squared. This is x minus 4 plus I, x minus 4 minus I. With something in front, you can have it in general. Of course, this 2 is x squared minus 2x plus 1. To do this product, you rewrite this as x minus 4 minus I and x minus 4 plus I. The reason you do that, because I'm reminding you that this is, in essence, everybody, this part is a minus b, and this is a plus b. So you get a squared minus b squared, which is x minus 4 squared minus I squared, which makes it plus 1. Or you can go with the bi and then say this product is a squared plus b squared. So this part is x minus 4 squared plus 1. Please understand the reason we do it this way, it's a lot faster. And now I'm going to leave it for you to multiply and come up with the answer. This is clearly x squared minus 8x plus 16. You add it to 1, and you multiply, and you get to this answer. So the thing I wanted to show you was to understand this and to understand how to multiply this to the easy way. Okay. Find the complex zeros of a polynomial function f of x equals x to the power 4 plus 2x cubed plus x squared minus 8x minus 20, and write it in factored form. Again, clearly the degree is 4, and therefore we must have 4 complex zeros. As far as the rational zero theorem is concerned, minus 20 over 1. And boy, we have a lot of factors. So this one has plus minus 1, plus minus 2, plus minus 4, plus minus 5, plus minus 10, plus minus 20, and this is just plus minus 1. Therefore, those are the possibilities that they are a lot. So we start with number 1. One and 2 and 1 minus 8 minus 20, that ends up being negative 24. It's not 0. That was my point to show you, when you work it out, sometimes things do not work out. If you plug in 2, it ends up being 0, and I leave it for you to prove that. But since it's 0, you are going to go with the synthetic division. And you're going to put 2 here, and then 1, 2, 1, minus 8, minus 20. You go through the process. Again, you drop the 1, times 2 is 2 and 2, 4, times 2, 8 and 1, 9, times 2, 18 and negative 8, 10, times 2, 20 and negative 20, 0. And now what you have as a result is x minus 2 times x cubed plus 4x squared plus 9x plus 10. That's what you have. Now this, you have to work on them again. It so happened, again, there are so many of these numbers. Of course, we've already proved the 1 doesn't work. So you really should try the 2 again, see if this is divisible by 2, and it's not. You try negative 2 and it works. And when it works with negative 2, which means you drop this one times negative 2 and 4 is 2, times negative 2, negative 4 and 9 is 5, times negative 2 minus 10 and 10 is 0. So that means now we have f of x equals x minus 2 times x plus 2 times this, which is x squared plus 2x plus 5. Now, x squared plus 2x plus 5, we can factor? No. Therefore, we go with the quadratic formula. Okay? If we were to set this equal to 0, x is 2, x is minus 2. This one uses a quadratic formula. Okay? Minus b plus minus a squared of b squared minus 4ac over 2a. The reason we use a quadratic formula on this part because it cannot be factored. So x is minus 2 plus minus 2 squared minus 4 times 1 times 5. This is 4 minus 20 is negative 16. And this one, remember, comes out as 4. So we have plus minus 4i. We divide everything by 2. We get negative 1 plus minus 2i. So the zeros are as follows. The zeros are 2 and negative 2 minus 1 plus 2i minus 1 minus 2i. And to write this as a factored form, we replace this part with x minus this and x minus this. We write it in the following manner: x minus 2 times x plus 2, x minus negative 1 plus 2i, and x minus negative 1 minus 2i. And you don't have to, of course, multiply them out because you already know the answer is this one, okay? It's been, the idea was to go from here to here, the factored form. Find the remaining two zeros of a polynomial of degree 6 whose coefficients are real numbers and has the zeros 2, minus 3, 2i, 1 minus 2i. Well, this, of course, is easy, given. This, of course, is given. 2i means we need minus 2i. This means we also need 1 plus 2i. So now we have all 6 of them. So 1, 2, 3, 4, 5, 6. This is just by the conjugate zero theorem or complex conjugate zero theorem. Find the polynomial of degree 5 whose coefficients are real that has the zeros 0, negative I, and 2 plus I. So we start with 0, and we start with f of x being just x minus 0 or x, but I'm going to go with a times x because the coefficient may be anything. This one, minus 2i, means also 2i is there. And of course, a minus 2i gives us x plus 2i. Minus 2i means 2i should be a 0, so times x minus 2i. 2 plus I, so x minus that, x minus 2 plus I. And 2 plus I means also 2 minus I must be a factor. And so times x minus 2 minus I. I'm going to leave it for you to do the multiplication. The only thing that I want to quickly tell you, I hope you realize this too. I'm going to just show you this one, and I'm going to leave it as that. I hope you recognize this one as x squared plus 4. And I hope you recognize this one. You want to do x minus 2 minus I times x minus 2 plus I. And now you can do the product. Convince yourself this is the answer. I'm going to leave it for you to finish the job. It's important to be able to handle the algebra for this. Is 2 a 0 of the function f of x equals x cubed minus 4x squared 4x squared plus 9x minus 10. What about negative 2? And now we want to see how we use a calculator for that. Okay, so what do we do if in case we want to go with a calculator? Is a number a zero value for y equals f of x using a TI calculator? Number one, enter the function in y1. Click on vars variables number one function, y1 appears. Then put the number in parentheses, enter it. So what do we mean by that? First and foremost, you are going to put this into y1. After you put it into y1, you've seen that before. Now, we are going to click on vars. This is vars. Okay. You move it to the right, vars, and then functions, and then this appears. When this appears, you put a parenthesis next to it, and inside the parenthesis, you want what you want. For example, 2, y1 of 2. So you press, when it comes, you press enter, y1 of 2, and it evaluates it at 0. So is 2 a 0 of a function? Yes. Now, what about negative 2? We are going to do, again, the same. Vars variables, enter, and then now we put in negative 2, and it calculates for us negative 52. So 0 is a 2 is a 0 of the function? Yes. Negative 2 is a 0 of the function? No. And that's done.